Right, we've got a further maths polar coordinates integration problem here. Um, so this is from an Excel further maths paper. It's actually from the specimen paper. Okay, let's have a look. Right, so we've got this curve and it has equation r equals 4 plus cos 2 theta for this first quadrant. And at the point A on C here, the value of r is 9 over 2. So that means that length there is 9 over 2. Um, and the point N lies on the initial line. AN is perpendicular to the initial line. Here we go. And the finite region here is between this perpendicular line and the curve. That's what we got. And find the exact area of that region. Right. Okay. So now the first thing we need to know really is if we're going to find the area, we do need to know this angle here. So denoted on here as theta 2. And we can just use the curve here, the equation of the curve, in order to give us that. So when r is 9 over 2, which substitute in there, then 9 over 2 equals 4 plus cos 2 theta 2. That's just substitution into that equation. And when we work that through, that is going to give us that theta 2 is pi by 6. So that's this angle here. I'm marked it in grey now. Right, okay. So now this region here, I mean, this is sort of a kind of a normal pattern with these things is that what we're actually doing is we're finding the area of this uh, kind of sector. Sector's not a circle, is it? But this bit, and then we're subtracting the area of the triangle. Right, so let's find the area of the sector first. I'll just wind down a bit. Okay, so the area of the sector. Well, this is the formula we're using here. We're integrating r squared with respect to theta between 0 and pi by 6, and taking half of it. So why is that? Well, so if you don't know all this already, well, if you do, then I might want to just skip forward. But essentially, what we're doing is so imagine all these little triangles here with, well, they've got infinitesimally small angle. Um, defining them. But that's essentially what we're doing. If we think of it in terms of discrete integration, then we are adding all these triangles all the way around from theta equals 0 up to theta equals pi by 6. And the area of those triangles is going to be a half r squared theta. Okay. Uh, right. So that is just the area of a sector, isn't it? Half r squared theta. I mean, on the diagram, the two sides are probably slightly different lengths, but in the limit, as delta theta approaches 0, then those two lengths are the same. So that's where we got that derivation from. And we can substitute r squared in there for that. I expand it to give us this. This is between 0 and pi by 6 here, by the way. Okay, right, we've got this awkward thing here, cos squared 2 theta. But if we if we use this identity, we're using 2 theta and 4 theta. But that basically equates to that. All right. So that is what we've got there. And then if we just rearrange that, we're going to get that. And when we integrate each term there, we're going to get this. Okay, so if you're not convinced by that, pause the video and just check through that for yourself. Now, obviously, we're evaluating this between 0 and pi by 6. So all these terms actually are 0 for 0. So we just have three terms uh, that we have to worry about. And um, and essentially, if we work that through, we're going to get this, which simplifies to that. And again, if you're not convinced, pause the video. It's just a little bit of algebra, really well, to evaluate um, these trig functions. They're sort of standard ones, pi by 3 and 2 pi by 3. So that will work through to that. Okay. Right. So that's the kind of the hard bit, really, I suppose. Now what we're going to do is find the area of the triangle, and we can subtract one from the other. The area of the triangle is, well, it's half base times height, isn't it? So, half of the base. Now this angle's uh, uh, pi by 6. The length is, well, r. It's going to be it's 9 over 2. Okay, so it's basically that's half of the base, r cos theta. That's r cos theta, where theta equals pi by 6, times the height, r sine theta. Okay, so if we just convert that, and with what we know r to be 9 by 2 um, there. Um, Cos pi by 6 is root 3 over 2. And sine pi by 6 is a half. All right, so we've got all the bits there. We can just work that through to give us that. So therefore, shaded area is going to be the difference of those two. So it's going to be this area, the area of the sector, minus the area of the triangle. And again, just a little bit of kind of working through is going to give us that. So again, if you're not convinced, then pause the video and work it through yourself. So I'm not going to go through that because that's not really what we're trying to get at here. We're trying to get at the basic structure rather than the actual working out. That basically is it. So that is the shaded area. And yeah, I'm actually written it out, but P is going to be 11 by 8, isn't it? And Q is going to be minus 3 over 2 from there. All right. So that's it. So kind of quite a nice problem. Actually, when you look at the steps, it's not really too difficult. Polar integration does seem to catch a lot of students out, but really it shouldn't be that difficult, really. So hopefully that has been useful, and thanks for watching.